Lies, damned lies, and statistics. You're watching Making Sense with Robbie. Let's get started. 2.74 billion people use YouTube. The average person watches YouTube for 41.9 minutes a day. 100% of people die. You're more likely to die in a plane crash than you are to win the lottery. Today, I want to talk about the uses and abuses of statistics. Statistics come from collecting data, putting that data into some software, and then doing some calculations, max, median. All of these pieces of information can be collected or they can be calculated given a set of data. And often, statistics is used to just sort of get the general sense of where the data is pointing, what the data is saying. So it's very important that proper statistics are used to make sense of data, to kind of come up with conclusions about that data, and to make that data useful and practical for making conclusions about what's been observed. But it's important to ask the question, where do those numbers come from? Like, do the numbers come from the government or do they come from Joe down the street? When the numbers come from the government, that certainly means that the data is more trustworthy, but what if the government is lying, or what if the government is providing faulty data? At the same time, it's like, if you ask just Joe down the street, maybe that's not a good data set, but if you ask everyone on the street a question, or some questions, then maybe you do have a good data set. It's important to remember that there are different types of data, and there are different qualities of data. While statistics does an analysis or a calculation of numbers and data, a big factor that has a huge influence over what comes out of that is the data itself. Like, where is your starting point? What information did you put into the calculations? That has a big influence over what the outcome will be. But the interesting thing is that numbers work. Like, using numbers is a good way to persuade someone into accepting a belief. And oftentimes people might even use statistics to convince you of something that isn't true. Like, I could say something like 94.3% of viewers of this video found this the best video on statistics. Obviously, that's not true. That just comes out of nowhere, but it might sound more convincing because I used an imprecise number, and I used a number as opposed to just saying that most people like this. What matters, though, is that numbers are very persuasive, and a lot of times numbers are used to convince people of things, to convince people that a statement is true or false, and the numbers maybe speak for themselves, or they have more importance or more influence over how someone makes sense of something than some other types of information might. But at the same time, there's lots of ways that statistics can be misused. One of the easiest ways that this can happen is if someone just simply does bad math. I remember taking statistics at university, and it was a pretty hard class. Now, I could probably do some calculations, but I wouldn't be the best person to do the calculations. That's something that's important to keep in mind. If someone is doing it incorrectly, if someone isn't an expert, then maybe they might make mistakes with the conclusions that they make with statistics. If you use bad data, if you use bad numbers to start with, then you're going to get bad outcomes. You're going to get bad results. And so it's always important to be considerate of the data or the inputs that are being put in. Another way that statistics can be misused is if there's no clear outcome or there's no clear objective. Like, why are you doing these calculations? What is the objective? Like, what are you trying to prove or disprove? If you're not trying to prove anything, someone might do something like p-hacking, and that's where they take data and they just sort of play around with the statistics to make conclusions or to say things about that data that aren't necessarily true, but can be sort of shown to be sort of statistically accurate. And while those are some of the issues that might come out of just doing math or just doing statistics the wrong way, there are even more sinister ways that statistics can be manipulated or influenced. These more sinister things might include things like loaded questions. And so you can ask people questions that are sort of framed in a way that makes them choose one option over another. At the end, you'll have a statistically significant result or outcome. It's not necessarily that that is what most people chose, that's what the question forced them or pushed them towards. Another thing that might influence the outcomes is a bias sampling. If you were to choose, say, conservatives or progressives, and you ask them a question, then obviously you're going to get different results. And so if you want to influence people to believe a certain thing, then you might decide to ask the people who agree with it what their opinion is. And so you're going to get a high bias towards like a support of that statement. Whereas if you wanted to say that people disliked this or disagreed with this statement, then you would, if you were to choose a bias sample of going after people who are more likely to disagree with it, then you're going to be more likely to get a negative sentiment. There's always ways that this can be done right, but there's also ways that it can be done wrong on purpose. And that's kind of more what I'm focused on, is how people can do it wrong rather than how people can do it right. On top of all of this, people are more likely to fall for really specific numbers. So if I were to say 76,453, that might be more persuasive than saying 70,000. While these numbers are pretty similar, using a specific number, people are more likely to think that, oh, well, that must be your true number. That must be a real number. Because why would they be so specific if it wasn't? If someone were to say something like 70,000, then you might think, well, maybe that's just like a generalization. Maybe they just came up with that number. Maybe they just made up that number. Kind of what I'm getting at here, though, is that statistics can be used, or numbers can be used to persuade people. And they can be used to trick people and convince people of things that aren't necessarily true. And you'll find this, often if you're looking at a sales page, they might say something like 95% of users preferred our product over another. And that might be true, it might not be true, but maybe you just ask people who bought your product what one was the best. And they don't have any other sample, they don't have any sense of reference. By providing statistics, it's easy to convince someone of something, or it's easier to convince them because it sort of acts like evidence, it sort of acts like proof, even if it's not necessarily proof. But because numbers are persuasive, because specific numbers are even more persuasive, then it's a good way to try and influence, to try and sort of frame someone's thinking or get them on your side. So often statistics or numbers can make things seem more scarier than they are. And so you could hear the statistics or the likelihood of dying in a plane crash. People are probably more likely to be scared of dying in a plane crash, but they're probably more likely to die in a car crash. But because you don't have this sort of sense of reference, you don't know how dangerous other things are, then we just kind of assume that the things that we do know that the dangers exist for are more scary. We don't actually know what, say, the generalized risk. You don't know what the risk is of you dying, this week or this year or whatever, but you do maybe know the specific risk of something. And so that might make it seem more scary, but maybe it's only slightly more scary or more risky than just your everyday actions. Just going to work or something is just as risky as these other things that you think nothing about. One thing to keep in mind as well with statistics is that correlation doesn't necessarily mean causation. So things can happen at the same time, maybe they happen during the summertime, and so they seem like they're related, but they're not. So you can take the same numbers and you can frame them in different ways. And so you could say you have a 75% chance of this happening, or you could say there's a 25% chance of something else happening. And maybe you're talking about the same thing, but it's just a matter of framing the numbers or the statistics to make it sound more scary, or it's more persuasive, or it's better for what you're trying to sell. And so people often use numbers to convince people, to trick them, or to get them to take actions. And those numbers are often meaningless without context, but we don't necessarily realize that we're lacking context. And so this is sort of the thin line, or that we need to be aware of and be considerate of, because there is this risk. It's yes, we can find better truth this way, but we can also be tricked or convinced of things that aren't true this way. My question to you is how do you know if you're being tricked with numbers? Why is someone using these statistics? Are they using it to be more honest, or are they using it to be dishonest? Let me know in the comments below. If you found this informative or educational, click that like button because I'd really appreciate it. If you are curious about learning how to think about things but you don't want to be told what to think about them, then click that subscribe button because I'd really appreciate it. You've been watching Making Sense with Robbie, and we'll talk next time. Goodbye.